9.4, recursive sequences. Recursion is the process of choosing a starting term and repeatedly applying the same process to each term to arrive at the following term. Recursion requires that you know the value of the term immediately before the term you're trying to find. So a recursive formula always has two parts. The starting value for a sub 1 and the recursion equation for a sub n as a function of a sub n minus 1, the term before it. In other words, in order to find the next term, you must always know the previous term. So you'll see it written two different ways in mathematics, and they mean the same thing. We're going to look at it this way. In the Regents and in New York, they sort of say it like this. Give you the first term, for example, a sub 1 equals 4. The current term, a sub n, is found by doing something to the previous term. Okay, this happens to be multiplying 2 times a sub n minus 1. So this is the same thing. The first term is 4, but here they write it to find the next term, use the current term 2 times the current term. Okay, they mathematically mean the same thing. Example 1. Write the first 4 terms of the sequence. A sub 1 is negative 4, and the recursive formula a sub n equals a sub n minus 1, the previous term, plus 5. So, if the first term is negative 4, which they gave us, we need to find the first 4 terms of the sequence. Well, a sub 2 is the next one we're looking for. And a sub 2 equals a sub n minus 1, which is 2 minus 1, plus 5. A sub 2 minus 1 is really a sub 1. A sub 1 is referring to the first term. So it's a sub 1 plus 5, which is negative 4 plus 5, which is positive 1. That's our second term. Our third term, we found the similar fashion. A sub 3 minus 1 plus 5. A sub 3 minus 1 is really just a sub 2, which is the previous term. So it's really 1 plus 5, which is 6. And the last term, a sub 4, is found the same way. It's a sub 4 minus 1, which is a sub 3, plus 5. A sub 3 is 6, and 6 plus 5 is 11. So, putting it all together, the first 4 terms of the sequence are negative 4, 1, 6, and 11. Example 2. Write the first 5 terms of the sequence. A sub 1 equals 3. A sub n equals negative 1 to the nth power times 5 times a sub n minus 1. So there's a little bit more here with the negative 1 to the power of n. So the starting value they gave us was 3. A sub 1 is 3. We need to find the next 4. So a sub 2 equals negative 1 to the second power times 5 times a sub 2 minus 1. A sub 2 minus 1 is just a sub 1. And negative 1 squared is positive 1. So 1 times 5 a sub 1 is really just 3, right? A sub 1 is 3, so we'll substitute 3 in for a sub 1. 1 times 5 is 5, and 5 times 3 is 15. So our second term is 15. Our third term, do the same thing. We plug in 3 here and 3 here. Negative 1 to the third power is negative 1. It stays negative because it's an odd power. A sub 2 gets replaced by 15. So now we have negative 1 times 5 times 15, which is negative 75. The fourth term, plug in a 4 here, plug in a 4 here. Since it's an even power, negative 1 becomes positive 1. 5 times a sub 3 is negative 75. So 1 times 5 is 5, and 5 times negative 75 is negative 375. So a sub 4 is negative 375. Okay, one more to go. We plug in 5 here and here, and we're looking for negative 1 to the fifth power is -1 because it's an odd power. 5 times a sub 4 is, where we're going to replace a sub 4 with -375. And -1 times 5 times -375 is positive 1,875. So, putting it all together, here is our 5-term sequence. Okay, you do number 3. First term is 2. Second term is found this way. Plugging in 2 here. A sub 1 squared plus 1, so it's the previous term squared plus 1, which is 5. Third term, plugging in 3 here. We're looking for the previous term squared plus 1. 5 squared is 25 plus 1 is 26. And the fourth term, a sub 3 squared plus 1. A sub 3 is 26. 26 squared is 676 plus 1 is 677. And our first 4 terms of the sequence are 2, 5, 26, and 677. Sage and scribe number 1. Find the first 4 terms of the recursive sequence defined below. First term is -3. And here's how you find the next terms. Okay, your recursive formula. Plug in a 2 here and a 2 here to find a sub 2. It's really just a sub 1 minus n. N needs to be replaced by 2. And a sub 1 is -3. So it's -3 minus 2, which is -5. Third term. A sub 3 minus 1 minus n becomes a sub 2 minus n. A sub 2 is -5. And the nth term, this is 3. This is the third term, so n gets 3. -5 minus 3 is -8. Last term, a sub 4 minus 1 is a sub 3. A sub 3 is -8. And since this is the fourth term, n gets 4. -8 minus 4 is -12. Ladies and gentlemen, the first 4 terms of the sequence are -3, -5, -8, and -12. And there's your lesson on recursive sequences. Good luck to you.